Hello developers, in today's video we will know how to generate PWM signal using ESP32. So, let's get started. The main definitions in pulse width modulation are: the period, which is the total time of one complete PWM cycle, including both high and low phases. It is the inverse of frequency. The pulse width, which is the duration for which the signal remains high in a single cycle. It is a fraction of the period. The duty cycle, which is the percentage of time the signal remains high in one period. It determines the average output voltage. And the PWM resolution, which determines how smoothly we can control the signal. Imagine adjusting the brightness of your phone screen. If you only had 4 levels, it would jump from dark to bright in big steps. But with 256 levels, you get smooth and precise changes. Higher resolution means better control over brightness, speed, or power. In ESP microcontrollers, the peripheral that is designed to generate PWM signal is the LED control or LED-C peripheral. The LED-C peripheral controls LED brightness and generates PWM signals with 8 independent channels. These channels are split into 2 groups, high-speed hardware-controlled, and low-speed software-controlled. Different clock sources can be used for each group. Now let's see the steps to generate and control PWM signal. First, we need to configure a timer by specifying the following: the timer that will be used, the timer speed mode, the PWM signal's frequency, and duty cycle resolution. Second, we need to configure a channel, by choosing the channel to be used, associating it with the timer and the GPIO pin that can be used as PWM to output the signal. Finally, you can change the PWM signal that drives the output in order to change the LED intensity. This done by setting a new value for the duty cycle, and then apply or update the duty cycle. To know how to create and configure an ESP-IDF project in Visual Studio Code, watch this video. We will need the free RTOS and LED-C libraries. We are using 12-bit resolution for smooth control, which gives 4096 levels. Here you can see all the available resolution options. The max duty cycle we can have is 2 to the power 12-1, which will be 4095. We will generate the PWM on GPIO pin 25. Here you can see all the pin macros. In the main, we are creating a PWM task with a stack size of 2 kilobytes and priority 5. First we are configuring the timer which will generate the PWM signal. I'm using timer 0 and high speed mode and giving it the desired resolution and 5 kHz frequency. Note that the frequency can affect the max resolution as shown in the table. Second, we are configuring the channel that will be used to output the PWM signal. I'm using channel 0, here are the available channels. Then I'm giving the initial duty cycle and GPIO pin and using high speed mode and the timer 0 that has been configured. Now we can control the PWM signal. We will gradually increase the duty cycle from 0 to 4095. Set the duty cycle using this function, which will take the speed mode and channel number and the duty cycle. Then apply the duty cycle using the update function, which takes the speed mode and channel number. Add a small millisecond delay that makes the task enters the waiting state for smooth PWM output. Then we are gradually decreasing the duty cycle. If you want to enter the duty cycle as percentage from 0 to 100, you can use it like this, which will be mapped to the right duty cycle value, to be given to set duty function. Build your project. Connect your ESP make sure to select the flash method and COM port and your ESP32 type. Flash the code.